and for other purposes. So yeah, and I will be presenting today the processes in Erlang, and it's a big privilege because processes are really important in Erlang. And I would like to start with welcoming you and hi everyone. Okay, so how can we start this? So processes. So processes in Erlang are not the same as other processes in other kind of languages. Processes in Erlang are really cheap and lightweight. So you don't need to think twice before spawning a process, before having a process, before creating processes. So if you have the ability to create processes, just do it because it's really lightweight. It has around 600 bytes of on the heap, so you don't need to think twice. So yeah, so let's start. I would like to make it a little bit bigger. Okay, so processes, they have an identifier. It's called a PID, and we can actually the shell of Erlang is actually a process, so we can see its PID. We need to just say self, and we can see the PID of the shell. So these numbers, okay, so I can say this 0, it means that this process is in the current node, it's not in a remote node. So if it's in a remote node, it will be another number, more than, not 0, but another random number. So let's start to talk about processes. So processes, they are created by simple just typing spawn, and then you can write between those parentheses the stuff that you want to spawn as a process. So let's try a really easy function. Okay, so this spawn, it created a new process which executed the function that formats the word hello. So we have also, we can see here that the process was, the PID of the process was also printed because it was the last thing that was printed. So it also wrote hello in the shell. Okay, so any code in Erlang needs to be in a process to run. So they are really important, and as I said, they are really cheap. And then you can even spawn like 30,000. Let's not say million of processes, but really big number of processes without having a big footprint on the node. So okay, so let's continue. Okay, so processes, they share no memory with each other. So if a process has a problem, it will not bring down the whole system. So processes, they are quite independent from each other. If you ask them to not be independent from each other. So if you ask that process be related to one process, then there would be a problem if something happened to one. But in general, processes, they are quite separate from each other, and they are independent, which means that they will not have a problem if one of them dies. So that's why it's good to have the right amount of processes. Okay, so we have another type of another way of spawning a function. You can write spawn and the name of the module, the name of the function, and then the parameters of the function. So you don't need to have a specific way to write the function in spawn. You can just write the module.
When the second thread was executed, then the I/O and the double dot, so that means that's module.
I/O is
which you invoke the format function.
Yeah, I/O and then
I/O and then
column, and then you write.
And the end is needed to close?
Because it's a function, it's an let's say an anonymous function that you just called inside the spawn. So you have two ways. You can call a function by just executing a function that calls the modules and the function, or you can just directly write name of the module, name of the function, and then the parameters inside at least. So you have quite similar result because it just prints whatever you give it, and then prints
the former was an anonymous function then.
Sorry?
In the body.
Yeah. In the body of the function. Yeah. So and okay, PIDs are a special kind of type in Erlang, and you can use it to identify the process so that you can send to it or know where is it coming from, if something is coming from another process. So it's a way to identify. It's an identifier of processes. So let's continue. And okay, so I mentioned that self will print for you the PID of the current process. So yeah. Okay, so let's talk a bit about Erlang and the scheduler. So here I have in the page in the Erlang tutorials, you can find what I was speaking about, and then now I will speak a little bit about how Erlang and scheduling works. So the Erlang VM, the particularity of it is that it's kind of bound to the machine CPU, so that if you have 4 cores, then Erlang VM will try to use all of them so that it can run the processes in a very efficient way. So that, for example, if you have here in the scheduler, it's like is taking using the core as to work on the processes that are running in the VM. So for example, if you have a lot of processes that are running in this queue, and then a lot of processes that are running here and nothing here, then it will be balanced quite there is a logic how to balance the processes. So there is a preemption, which means that some processes will not be executed if they are executed too many times on that scheduler, so that other processes don't starve. So there is a logic that is going on here, and then they are used in a way that not, for example, a scheduler doesn't use too much resources and 2 others use too many or something like that. So they balance the load quite efficiently. And the processes, they have the priority level that you can set, and there is also the reduction number that I said, which is the number of executed function. If it reaches 2000, then the scheduler will either stop executing that, or another scheduler will take it from there. So yeah, the scheduler is responsible for taking the processes and making them as a work to do. So there is always work to do, and then if a scheduler doesn't have work, there is also some strategies to shut down or to make it like in a kind of way that it doesn't use energy. So Erlang also cares about usage of energy. So it also has that kind of logic of stopping schedulers from taking work. Okay, so processes. There are kinds of how to say, the processes when they have a life, but also when they finish. There is 3 ways that they are finished. Either they are finished executing their task, or there was an exception that happened and it made the process finish, or it received something from outside that said that it should finish executing. So we can, for example, try to spawn something just to show how these things work. Let's create a function which takes parameter and then, let's say, divides it by it. Okay, so let's have a list comprehension, and then let's try to divide by 0. Let's spawn. Okay, so this list goes from, actually let's say just okay, from 3 to 0, and then it will spawn a function which will a process which will divide 7 by the number that we will provide. So
don't you mean to write font x gx or because I think this will call
it will call
right there.
It will call the function because we already named it j here.
Yeah, but this won't spawn anything, will it?
It will spawn.
All right, let's just see.
Oops. Okay, so just a second.
Yeah, so if you want J to be exactly right in the new process, then you need to write spawn, colon, and then put it into the, fun, arrow, GX.
Oh yeah. Oh, that's the problem.
Yeah.
Yeah. That's the problem.
And the colon, the parentheses after. I'm in here.
Oh yeah. Oh. Okay, so it executed all the functions, the processes, but when it arrived to the one where it should divide by 0, it generated an error, an exit value, and it will tell you exactly what the problem is. 7 divided by 0 will but arithmetic expression, which will generate an exit value that will kill the process. So let's try to continue. Okay, let's try now to see how the processes, when they are spawned in parallel, how they work. So let's have a timer that sleeps for 10 milliseconds. And then executes and writes the value that it will take. Okay, so we have a function. So let's now try to quite similarly.
Did you want to build something in Erlang? Because the didn't.
Sorry.
And you need to close the spawn because he thinks that you are inside the spawn line.
Oh yeah. Just a second. I think now it's fine.
Yeah, now it's fine.
Oh, same name. Okay. Okay, so let's try to spawn a function.
maybe you want to write function h instead of g.
Yeah, that's
And
it.
after the end, you want to have a closing.
Okay, so this is this will take a sequence from 1 to 10. It will assign the value to x, and then it will spawn a function that will wait 10 milliseconds, and then will format the x that we provided. So just to see that they will not be printed in a sequential way, but because they are spawned in a parallel way, they will be printed in a randomized way. So. Yeah, and of course you can see that here because the shell executes this, so it will write the PID in the list that we provided. That's why you see the PIDs of the functions that the processes that we spawned, they will be written here in a list. And I think not all the time it will be the first one, but I don't know now why is it always printing the first list first, but it can appear anywhere because the shell process is also I mean this one.
Because of the sleep then.
Yeah. Okay, so one other thing about processes is to register them. So registering a process will allow you that you don't need to, because we will come for it in the second part, because we can send messages to processes, and then you don't need to always have the PID. You can register it, giving it a name, and then you can just send directly to the registered name. Let's have the PID. Just to have some, just to show that we can have the PID register it, and then we can see that the process will have a time that is alive, and then we can see that if we try to reach it, it will not be available because it's already exhausted. I mean, the timer it's finished after 60 seconds. Okay. Let's try now to register it. We give it a name and the PID. Okay, it will return true when the PID gets the name that it has. So after 60 seconds, it will not be the same because it will exhaust the time. So we can also know the PID by writing the name. And if we wait enough time, it will not be available. So yeah. Okay, so let me. Okay, I wrote the example here, and then you can see it's not defined anymore. Okay. I don't know if you can have it. I don't know if 60 seconds already passed or no. But yeah. So it because it executed what it has to do, then it just went. Okay. So
why is it that? Garbage collectors aren't registered themselves from the stack.
why is it? Because the process already exhausted. I mean, you executed timer sleep for 60 seconds. That's it. You didn't ask it to execute anything else.
The timer is continuously looping indefinitely.
It's not looping because it's no. We didn't ask it to loop or anything. It just executed the timer sleep 60 seconds. That's it. We didn't ask it to loop. Yeah.
And all the functions related to them regarding the name is undefined, becoming undefined, right?
The process is becoming
inside the process, because we define H and G as functions to be run inside the process. So then it becomes undefined as well because they are global variables.
No, they are still. So if you type H, for example,
it's not undefined.
It's still there. The function will not go because it's not the same as process. A function, it's executed by a process. A process has a life, but the function is just a definition. It will not die.
Defined, it's defined previously separately. Yeah, I see.
Okay, so processes also has a good feature, which is that it has a mailbox. It can receive messages from the outside, and it can work what it needs to do based on those messages that it received. So here it's a little illustration to show that a process will have a receive block inside it that will actually I will not speak about receive first. I will speak about the mailbox. So if you send messages to a mailbox, it will just keep them and then try to check on a kind of a case block. If the message matches, then it will do the first thing that it has to do. So I will show it for, of course, an example, but just to understand that if the first message is wanted by the process, then it will be removed from the mailbox, and then the corresponding execution path that it will happen. And actually here misses an arrow that we have to call again the process so that the receive is again initiated, so that it gets the next messages. Because if it just receive and then execute what it needs to execute, then it will just finish, because that's what the process is needed. But if you call again the process, it will again check the mailbox, and then it will execute until it just finishes messages, or it just has. We can also define a timeout. I will show it in a few moments. So just because of Erlang, we use a lot of this ping-pong terminology. So I wanted to just show you a very, very simple way to use processes to communicate and how they work together and how the receive block is done. So let's just try to okay. So this is a way to not have to export one by one. You can just export everything in every function that you have in the module. You don't need to define which one you have to export on. So just to be fast a little bit. And okay. So let's have a run function that we will call. And let's have a ping function. So the run function will spawn the ping function. Actually, we can do this way. I think, yeah, it's fine. You can also define it this way. Just try to find, and then the function that is, and then the arity. Okay, so let's see. When we spawn the function, okay, so this is the receive block. It has receive and end, and then it will get a message. Let's say. And then we'll execute corresponding to what it received. It will execute whatever it needs to execute. So we will ping will receive a message containing the PID of with the one that executed it. Just okay. I'll try to. Okay, as we mentioned, self is the function that you call to get the PID of the current process.
What are the exclamation mark operators?
Okay, I will just explain it just in a second.
I think it's typo.
Yeah.
Sorry?
It's the other way around.
Receive.
Receive.
Oh yeah.
Yeah.
And
and in Ping also.
Oh. I don't know why it happened sometimes.
It's easier in Hungarian because we have a word preset.
Ah, okay. Okay, so this just I just try to. Doesn't want to zoom in, but it's okay.
Command plus.
Yeah, Command plus is not working.
Not working.
Yeah.
Let's look into it. Maybe the keyboard layout is not
No, actually, it used to be.
a common equation.
It's working here in the.
It should work there as well. It was a generic keyboard shortcut
Copy it into a new
for
tab.
MacBooks. You can see that.
You see, it was working too much.
So maybe it's the Erlang mode that doesn't let him
Yeah, I think
to
it's.
scale. Erlang doesn't let you scale.
Yeah.
So in the function ping, you didn't receive any parameters.
Okay, so here we are spawning the function ping. So this
Yeah.
one will be a separate process which will run this code inside it, which will wait to receive some message. So this one will just, the PID here, it will contain the PID of the spawned ping function here. So it will be running on the side and waiting to receive a message. And then this sign is to send. It's like it's the notation meaning that we want to send this self to the PID of the function. So
I see.
so the self will be sent to the PID of the process, and then it will receive it here, because it was waiting for something to get to be received, because we have spawned it. So when we send it, it will be here received. And here we didn't specify anything. How to say? We did not specify anything. We just said just anything that you receive. Just send.
Well, it's not the self, it's the spawned font. It's a spawned process. What you are
Sending
the PID.
Yes.
Not self.
Self.
To be sent.
Self is the PID of not this one, but the PID of the run. The process that is. So we send it to the PID of this one, because we spawned it here. Do you understand it?
Yeah, it's a bit confusing.
Okay, so
it's like the main thread. It's like the main thread. Actually, it's not really separation of the concepts of the concerns in semantic way. So in my mindset, it's like the same process in the same stream.
that's why I told you.
Thread.
That's why I told you when we spawned the ping, it's like separate. It's like,
okay, we have
let's
the
say
PID inside the PID. But the self means in semantic way is not the spawned thread.
No.
It's something else, the main.
This self, yes, is this self.
You are sending to the main, the PID.
You're sending the main thread to the PID process.
Here, first you put the one who will receive it. Here.
So you're sending the self to the PID.
Yeah. The receiver comes first.
The right, what you're sending to the left.
The receiver comes first, then your message comes second,
God.
and then you send it to the process that you have spawned here, which is we have the PID of it here. Okay, so let's say that we send it here, and then the receive will get it here, and then we'll send the pong to the from.
Yeah, understand.
That's why it just
I
send
totally
it.
understand. Yeah.
So the pong will get to this self, because we send it. This self, it's here now. So we send it back. Ping pong. Yeah. So yeah, and then the receive will receive the pong here, and then it will just right. Okay. So let's try it. Don't know where I am. Okay, just. Okay, so it was compiled, and then we will execute the run, the first one that will spawn the ping, and then we'll get the pong. Then it will get the OK that we mentioned. This one. We can just write something else, like.
You are in the untitled.
Sorry?
You are in the untitled.
Yeah. You are right. So it just shows that it has received the PID correctly, and then it has answered to it because we send it by message here to the spawn function, which is running in parallel. So receive will wait for a message to be received, and then when it receives, it will execute what we give it in the body, and then it will just, for us, because it's a ping-pong function, it just send it back, and then it just execute what we have. I don't know if you understood exactly how this works, but
Just a very short question. This example seems to implicate that usually a received message doesn't contain information about the source. In this case, the PID where this message came from should be sent in advance to know where to return an answer.
yes,
true?
It's not sent here, but we sent the self already, so we know.
I'm talking about the ping process had to get the source of the message as a message.
Yeah.
So that's the general case. So usually an Erlang message doesn't contain information about the source of the message.
Well, the way that it's done is that we usually do this, and then we write the payload. So we know exactly where is it coming from, and we know where to send back. So I don't know. I didn't get exactly the concern.
So the answer is that there is no built-in way for the sender speed to be in the package, but often it's useful to have it. So in that case, you can just create a tuple or whatever and put it in yourself.
Okay. Because usually a message in a general sense refers somehow to the sender. Think email, for example. This is something like that. Every message is anonymous.
Mm-hmm.
We just have simple authentication, what we can refer to. When the thread pool exploded, so I mean a lot of threads there are, and we have to authenticate which threads has the priority to run, for instance, or which has the which comes from a user, for instance, and it's not having the authentication to spawn a thread.
Yeah, but in this way we know where it comes from, because
okay,
in Erlang.
In a server side, but sometimes it could be useful to authenticate the thread ping-pong. I mean.
Yeah, in a production system, of course, you will have to do more than just from. Yeah. But this way, just to illustrate that we just wanted to send a message, and that message served us to send back. That's why we just send it. We could send it in another way. We can send it like this, and then
the \0. I didn't catch it.
It's another notation of of identifying functions. So this function, because it's in this module, we can call it just by its name, and then the arity, the number of parameters that it takes. But if it was in another module, we have to put the name of the module and then this way, and then call the function.
Yeah. So it's default parameter, the 0, what is it?
You have to write the arity, the parameters, the number of parameters of the function.
You can overload functions, but
Yes.
everything in
Yeah, because if
You can overload function.
yeah, of course, but not of course. Yeah, yes, you can.
yeah, because
Therefore,
we can have ping which has 3 parameters, or 2 or 1, and the way that we want to identify is by the arity here, so that
You should check previous lessons.
yeah,
Yeah.
it's just another way to
Yeah.
function.
Yeah. it's a way to refer to the function that is in the module. Okay.
Can I have one more question?
Yes.
What happens if the receive block is not exhaustive, so it's not all the patterns
Are matched.
Matched, yes.
It will just be on hold.
Okay.
I mean, it will just wait, but that's why we there is another here. We can call it. Okay, so if it doesn't receive anything that is could be matched in the receive, then it will execute. It will finish executing after 2 seconds.
Okay.
Or if we didn't write this, it will just be on hold. It will just wait.
Does it mean that we can fill up the message queue?
Yes, it can be filled up. Exactly, yeah. That's why there is a way to just cleaning up actually this way, just to not have overloaded.
So it's not going to automatically drop any message which is not met in the receive block? Okay.
No. Okay, let's have another example which is a little bit more... Actually, I would like to... Okay, I can have another one. Okay, let's have an example which uses most of the... Yeah.
If one thread sends a ping, which the other thread would execute or evaluate, I mean invoke the function which doesn't exist, for instance, then it's after the block didn't find the pong, and it's just waiting. So, for instance, it could be DDoSed. The other as it's fill up the message queue and waiting, so it just becomes stack overflowed.
Yeah, so here
You're sending some undefined functions which couldn't be executed, or the from is not identified.
yeah, we are in one era of virtual machines, so the functions and the code has to trust one another. You can write a function that will overload the message queue of a process, yes.
Yeah, that's a shame.
But I mean, in any programming language, you can write a line that will cause an exception and start a virtual machine. It's not like, processes are not like different machines in a network that cannot really trust each other.
But it's not so.
Okay, so I just made an example. Just it's like a drone that we want to send message to. We want to say take off, land, stuff like that. So just to define. Okay. Okay, so it will.
Same type.
Oh, yeah, this is a problem.
That's why you have syntax.
Yeah. Okay, so a drone that we can send messages to. So messages that will be in the receive block. So that, for example, we wanted to land, to take off, and some other thing that it couldn't do. So let's say. Okay, if it gets the message land, it will just land. Anything else for example, and here, of course, oh, okay. Yeah.
Nice.
Actually, I want to see what is it. Yeah.
It's reproducible.
But it's probably a feature, not bug.
Yeah, it's maybe related to some syntax rules, but
Change the syntax to
JavaScript.
to JavaScript. By the way, Java, just to mention, beside these threading things you mentioned, it's getting on hold. JavaScript,
HTML.
the most hated languages in the world, JavaScript is not doing that. The worker rule, when it's receiving a message, in the background tab what I told you before in lunch, it's not getting on hold.
Right, let's discuss
So it's
that after
just-
this presentation is over.
Okay.
Just exit,
Okay, so
and that's all.
let's just okay. So now we have a drone that we want to spawn as a process so that it can receive messages and okay. Actually, we can just do it like this. It should work. Yeah. So actually, I should have put the PID somewhere so that we can send to. Okay, so let's send to the PID to take off. Actually. Okay, so it will just write me again the message that I sent, but to see the message, to see the response, we need to just flash, right? Taking off. Maybe I should do an IO format.
You didn't send back any response.
Sorry?
You didn't send back any response. I mean, the
Yeah,
code doesn't have any.
Yeah, I just put the
Yeah.
string here. Yeah, so it's.
You just showed that you don't have any messages yet.
Yeah.
Don't you have to put the anonymous function format?
Which one? Sorry.
Function. I mean, the take off, as it's just a function. No?
No, this is the message that it will receive.
Mhm.
So it will just IO format, just executing any Erlang code that you want to execute. That there is no obligation to put any anonymous function or anything here, so you can just execute anything you
Okay.
just to. Okay. Okay, so it just wrote what we wanted it to do, and just also printed the message that we sent. It's just a way of Erlang of I don't know what is the reason behind it, but
The reason is that if you have two processes,
Mhm.
like A and B, then you can write A exclamation, B exclamation, take off, and it will be evaluated from the right hand side. So B exclamation take off, so we will send the message to B, and then the value of this expression will be the message take off.
Yeah.
So we will send that message to A as well, because then A exclamation and then take off.
Okay, so
But I have never seen this
Yeah,
used,
yeah, me
so
too.
it like probably sounded good when they designed the language, but
yeah,
not actually useful.
so because they are considering this as a message, and then you can even send it to another. Yeah. Okay.
Just an expression.
Yeah.
Anything else in Erlang,
Mm-hmm.
the value of the message.
Okay, so why is it not evaluating the land now?
Because we're not recursing back to.
Exactly, because the the process has finished executing what it has to do. So the only way that we want it to take another request is that we have to call again this function after taking off, so that it's still in the loop. Actually, it's still in the receiving messages. So we call it again, and we do the same in the when landing, because we want to ask it also to take off again. Otherwise, it will just land and then finish. So let's okay. Okay, it's taking off. Now let's ask it to land. It will land and execute also print the message that we sent. So now we want that when we ask it to land, we want to know if it's already landed or no. You don't want to ask the drone to land when it's already landing. So how can we share that information? We can have it as a input, so that the receive will know if the drone is up or down. So we can just call it state, and then when it takes off, we need to know, is it landed or is it in the air? So we can just we can have actually I wanted to actually also make the after block, let's say 80 seconds. It's a very bad drone, and then the batteries died, so that after 80 seconds it will just complete the execution. Doesn't matter if it's it will wait 80 seconds and then it will just die. So just to show that we can okay. So the state. So we want to only take off when we are already on land. So let's have a guard. I don't know if you already mentioned the guard.
Yes.
Okay. Okay. So we want the state to be landed, let's say. It's becoming a little bit ugly, and when we land we want it to be, let's say, this way, and when we call again the function drone, we need to pass the state so that it can execute. So when we pass the state, what should we write in the state here? Okay, and for landing, landed, so that now we can just know if it's landed and we can ask it to take off. Okay, so let's try to, we spawn the drone. I'm sorry, I'm changing the
Drone 1.
Oh, sorry, yeah, you're right. And it shouldn't be like this. We want to pass
There was an end notation where the 3 parameters spawn.
Yeah. We can use that. Yes. So the drone module, the drone function, and the parameters, which will start as landed. Yeah. So let's try it. Actually, maybe Q was already. Okay, let's send it. Now it's counting 80 seconds now. And yeah, so let's tell it to take off. Let's tell it to take off again. I cannot do that because it didn't match with the other. It didn't match with this one. because it needs to be landed. It didn't match with this one because it needs to be in
When
the
we
air.
are finished,
Yeah.
because
But
there is no.
It matched with
other-
the so it just
Yeah.
and you can tell it only to land.
Yeah.
Only to land now, I think. Yeah.
No, it's already
No, it's
already
wrong.
crashed.
Our program is currently wrong.
Yeah.
Because the
Oh yeah, it's yeah. We
It's
need
not handled,
to
it's-
we need to call drone again here
It's
with a state that is
state.
state.
same.
Okay.
Oh, but it can be.
So I know that
How are these bindings are forgotten in shell?
With the F.
yeah. So yeah, let's ask it to take off. Take off again. It cannot do that. Let's ask it to land now. Okay, it will land. Anything else, it cannot do that. And after 80 seconds, it will just say that the batteries died. So it's like a small function that just shows different kind of features that you can have, and then so this is the state, and that's why we needed to have it to put it again to call it again here, to put it again here, so that it remembers. That's the only way that it knows.
Just a faint note, after each command the battery will be automatically reset in this funny thing. Another thing for demonstration, let's do the following. Remove that all handling case.
Which one? Ah, this one.
Yes.
Okay. To remove it
Yes.
completely. Okay.
Then spawn the drone.
Mm-hmm. Yeah.
Compile. Compile.
Oops, sorry. Yeah. Yeah.
Okay, now tell it to land and then tell it to take off.
It did not.
Yes, now tell it to take off.
It's the previous drone.
Yeah, the previous one.
Previous one, yeah.
The previous drone died. Yeah. So now take off.
Yes.
Yeah. So what?
Everyone sees what's going on?
Yeah.
The message queue.
Yeah, because after that it was called again with the state. Before
It has emptied
So
the,
it should
emptied the
be-
message queue.
landed, when it was taken off.
But let's do with the state. It has to do simply with the message queue.
But it's not a real
Messages
ping-pong,
don't
it's a ping-pong.
Messages don't disappear.
Because
They
of
are.
recursivity of the
you
receiving.
Do you want to explain or shall I?
You can go ahead. It's
So the point here is that when you have a receive block and you have branches, then you have a mailbox. The first such message will be read from the message queue, which matches any of the patterns. So here we sent end, but this message didn't match any of the branches, so nothing happened. Then we sent takeoff, that was the second message, and that did match the branch about taking off. So it was removed from the message queue. And then now the state of the drone went to in air, and then we get the next receive, which meant that now, because the states changed, we did match to the landing message, so it did land. And even though we told first to land and then to take off, it first took off and then landed.
Yeah.
So to avoid this kind of confusion, when there is a possibility of something like this, what we do is that we generate for each message a unique reference, and we put that reference into the message. And then the selective receive will read the
But this
reply in the
behavior can be
corresponding.
useful as well.
Yeah, it can be useful, but not, it's hard to see
Not in this context.
example, but yes. So for example, you can send special messages.
Several
Okay.
tasks, but you only want to deal with them and you are ready to do that type of task.
Yeah, of course, this is the reason for having this selective receive. Yes.
Okay, so that's about it. I think we can have the exercise now. It's a bit long one, but yeah, we can have the exercise.
Thank you very much.
Thanks.